Hello everyone, welcome to the Realize Live 2020 virtual conference. Today we'll be discussing about implementing MindSphere for thermal spray robots. My name is Canon Armugam. I'm part of Siemens Energy's digitalization team. I'm currently leading multiple VLM projects in the digital manufacturing area. We'll start with the introduction to Siemens Energy, which some of you may know. Then we'll move on to the current process being used for managing the thermal spray robots. Later on, we will be discussing about implementing MindSphere for thermal spray robots, along with the lessons learned and what our future plans are. Let me start with introducing our project team. Along with myself, we have Dr. John Gojan, who is the business lead and the key business beneficiary, along with the soft floor supervisors on this project. We also have a team of MindSphere experts, both from Siemens Energy and Siemens PLM, involved on this project implementation. Siemens Energy is one of the key players in the renewable energy space. Today, we'll be discussing about implementing MindSphere for the power generation unit, which designs and manufactures gas turbine generator and large steam turbine units. This MindSphere implementation benefits our service center in Winston-Salem. We basically repair, make new spare parts, classify the parts as scrap, and plan on long-scale scrap recovery and so on. The power generation service division basically services large gas turbine, steam turbine, and generator components. It usually involves repairing the components or making new spare parts in case if it cannot be repaired. The repair process basically involves inspection, both like non-destructive testing and by using systems like blue light scanner, x-rays, and so on. And later on, it will be followed by machining, welding, and thermal coating using the thermal spray robots and laser drilling whenever it is necessary. This specific MindSphere implementation project focuses on managing the thermal spray robots and booths data using MindSphere. As most of you know, implementing MindSphere usually is not the first step on the entire digital manufacturing process. We usually start with implementing a 3D CAD/CAM process and move on to implementing DNC, tool transfer, MRL kind of an activity. Later on, like team center manufacturing to the software connect interface, then eventually get on to the full-fledged MES implementation or manufacturing operations management implementation. Once we reach to the point that where we have some level of an MES MOM system in place, then we'll be discussing about implementing an IoT-based real-time data collection, do a data analytics, so that we can continuously improve the performance of our system. This is where the MindSphere come into play. MindSphere's out-of-the-box capabilities and the features that's available makes it very easier to start the implementation in a digital manufacturing environment where we already have Siemens PLM products. Now let's move on to discussing about the current process being used for managing the thermal spray robots. So if you're not familiar with thermal spray, it's basically a process of applying material coating on top of the components, especially ceramic coatings, which reduces the corrosion and increases the life expectancy of these components. There are like wide range of thermal spraying options: thermal spraying by liquid, thermal spraying by gas, and thermal spraying by electric gas discharge, and so on. The thermal spraying is predominantly done by robots. This is primarily because that increases the accuracy, quality, and repetitivity of this process. It also helpful in terms of the work environment and worker protection. As you can see from these attached pictures, the same thermal spray robot is usually connected to multiple input sources so that they can be used for different types of thermal spray. So the same thermal spray robot can be used both for high velocity flame spraying as well as the plasma spraying in the chambers. But the robots usually perform only one of the operations at any point of time. So in our service center, the operator usually loads the part, enters the part and program details on the controller of the robot. Later on, they usually record the start stop time and the task details such as like the service number, order number, part number, and so on, to make sure that they are tracking the progress of the specific job. And eventually, for every day, the supervisor spends an hour or so to verify that the details entered are correct and makes sure that it can be tracked at later point of time. The data entered by the operator is stored in a SQL database. Later on, a report can be generated from this database to basically for all the thermal spray robots that we have in our place. One of the main report that gets generated as of today is what we call it's a downtime report. This basically has the list of different reasons for which, because of which the part has been not processed or the robot has been shut down and not in working in an operating conditions. Because of the fact that this data is manually entered by the operators, listing out these various reasons, the information, the quality of this information is trustable to a certain extent, but if there is any specific concerns comes up, it usually takes time to debug and analyze to find out what exactly happened during a specific. Okay, now let's move on to discussing about implementing MindSphere for thermal spray robots. Now, let's look at this thermal spray process for a minute to understand what it's exactly doing. Basically, you are seeing a thermal spray jet applying a ceramic coating onto a component. Basically, the quality of the thermal spray is measured using the spray coating thickness. But the even coating of the spray is affected by various factors like the booth temperature, voltage variations, and the time taken to actually complete the spray and so on. The historical process involves manually entering data into the SQL database and exporting to an Excel spreadsheet and reviewing to find any possible problems. This current process has some limitations. Often it is very difficult to verify the quality of this information. And also the frequency of this information is not sufficient in some cases. So basically it becomes necessary for our process to improve the quality of the data collection and also the frequency of this data collection process. So the goal of this project is to provide accurate and consistent process data without the operator's intervention, to support the documentation of the booth utilization and also to support the process trending and troubleshooting efforts. So eventually we are trying to collect more data, more metrics, so that we can provide more dashboards and better data analytics. Our project scope to implement this MindSphere for thermal spray robots and booths has been put into multiple phases so that we can get these things done in a step-by-step approach rather than doing a large-scale big project planning. The scope of the phase 0 or the pilot project is basically install the MindSphere tenant and install the MindSphere IoT boxes to one thermal spray booth and robot to make sure that everything is working fine. The scope of the phase 1 is basically to demonstrate the feasibility and capability of the MindSphere for data collection and visualization through interfacing with the thermal spray controller, the Excel logbook, as well as the Fanuc robot. On the next phase, we basically wanted to extend the capability to additional systems, add more robots and more booths, and also use more of MindSphere apps for data analytics and visual charts creation. Now let's discuss about the implementation of the MindSphere for next few minutes. So the MindSphere implementation actually involves both the hardware and software part of it. On the hardware side, we have the IoT boxes like MindConnect Nano and MindConnect IoT 2040 are the two frequently used boxes that we used on our project. And on the apps side, there's a whole bunch of standard apps that's available from MindSphere. It's also possible for us to build. The implementation basically started with the hardware network connection side. So basically we have two IoT boxes. We connected the IoT 2040 to the Fanuc robot and the MindConnect Nano to the thermal spray booth. so that both of them can collect and read the data from these assets and then transfer them to the MindSphere cloud. Once it's uploaded to the cloud, then it can be downloaded and accessed by the MindSphere applications for either direct access or for processing. You can basically connect the existing sensors that is on the robot, or you can even introduce your own sensors like the heat sensors, pressure sensors, and so on to associate to the MindSphere MindConnect devices. Once you have this hardware side connection has been established, now we are talking about the a basic MindSphere implementation usually goes through these four applications: Asset Manager, Visual Flow Creator, Visual Explorer, and the Fleet Manager. So you basically start with the Asset Manager to create the assets. For example, in our case, the booths, robots, robot guns are the assets. And then you will also create the so-called agents. The agents are like MindConnect Nano, MindConnect Library, to connect the Excel spreadsheet, and the MindConnect IoT boxes. So these agents are basically a software representation of your IoT devices. Okay, and then once you create these assets and connect them to your physical hardware, as we saw in the previous slide, then we will move on to the Visual Flow Creator, which basically helps us to create the rules and logics to read the data that comes from this MindConnect devices, and then make any changes that is required. For example, if you want to add some validations, like if the incoming voltage is more than 80 volts, then that means that there is a part in it, and so on. All these logical assumptions that you want to make, you will define those rules using the Visual Flow Creator, which allows you to basically calculate value of additional variables to store it on your system. Okay, once that is done, then we'll move on to the Visual Explorer. So the Visual Explorer is a process application that helps you to create the dashboards. Okay, so you have Visual Explorer comes with the multiple licenses, one like an author license for someone to create these dashboards, and then viewer license for somebody who wants to just view the dashboard that's been created by the developers. Besides this, we also have the Fleet Manager application. The Fleet Manager application can be used to basically look at any asset and any time series data associated to that asset. Now I'd like to invite Steve Galbraith from Siemens PLM Software to give a demo of the Asset Manager, Visual Flow Creator, and Visual Explorer application. Steve, please go ahead.
Thanks, Kenan. So what we're looking at here is the MindSphere landing page for Rural Hall. And for this project, Rural Hall opted to use out-the-box offerings. And today I'm going to focus on three pieces of this. The Asset Manager, how we connected to the machines. The Visual Flow Creator, how we've taken that data and ran it through some program flows to get more useful information and more relevant data for what we're looking for. And then finally, the Visual Explorer for the visualization portion of the data in the end. So let's look at Asset Manager. We can see here we've got 5 machines configured, and all of these 5 machines are actually connected using 3 methods of connection. One, we're taking the spray booth information direct from the S7 PLC using a single MindConnect Nano hardware device. We're then also tying into the Fanuc robot to get the program numbers using once again a single IoT 2040. And then finally, we're using the MindConnect library to bring in data from Excel spreadsheets, which are put together by the operators regarding their downtime reasons, so that information is then imported into MindSphere. If we then look at the Visual Flow Creator, we're focusing on 3 main pieces here, which is the guns. the plasma gun, jet coat, and JP gun. When these guns hit a certain threshold, we then consider a part is starting to be made. And if we look at the plasma gun here, we can see 40 volts is that trigger point. And once another threshold is met, then we consider a part as being completely made. We're using hydrogen flow for the jet coat gun and chamberline pressure for the JP gun. We're then taking that information and then embedding it under a specific shift so we can identify which shifts have been running which parts and which guns. If we then go back to Asset Manager, let's take a look at Spray Booth 2, we can see that information that we created in Visual Flow Creator is here and it's now being pushed into MindSphere as a saved data point for visualization and utilization after the fact. So cycle times, gun type, part count, which program we're running, shift, etc. So let's have a look what all this is give us. So the dashboards that we've created using Visual Explorer, we've got 5 of them. The first one is program per shift. So you can see we've got a breakdown of the shifts and it's showing which programs are running. The ledgers here give you an indication of what the colors mean. If it's blue, it means there actually wasn't a program in the Fanuc robot. Other means it's a program which can be a trial program, setup program. It's not a production program. And then the green is showing which are the production programs. The cycle time per program lets you see exactly that, what the cycle time was per program, and it breaks that down on into particular dates. And you have the capability here to visualize a specific program if that is of value to you. So let's just take a look at this one. It shows it ran on the 9th, 6th, 7th, 8th, 9th, and it also gives you an average across the date range of how long it was taking to make a single part. The gun on time, this is relevant for EPA reporting. The Rural Haul team need to show how long each gun was running per month, which is broken down here. And then we've also got a date range selector for this total per gun, which will change that value there. In a similar fashion to cycle time per program, we're breaking down gun on time per program here, and it's showing us actually which specific guns were running for the programs and how long they were on. Once again, you've got all the filtering capabilities here on the right hand side. And finally, we've got a utilization, which is showing based on broken down per program, be it production or other or no program, and it shows what that utilization was per shift, per day, per week, and per month as well. And that is a very quick high-level overview of what we've put together.
Now let's move on to the next topic, lessons learned. For some reason, we were unable to connect the Fanuc robot using the MindConnect Nano device. So later we end up using an IoT 2040 box instead of the MindConnect Nano that we already had. Basically, establishing the network connection between the robots on the IoT box was one of the first step, and it needed people with a different skill set and experience. So bringing all of them on board to the job site for a day or two will make this thing move faster. Please go ahead and look at the specifications of the MindConnect Nano and IoT 2040 boxes because both of them are capable of connecting multiple devices at the same time to transmit the data from the assets to the MindSphere tenant. Now that we kind of successfully completed predominantly the first part of this project, we have additional steps planned for the upcoming period. Our goal is to add more thermal spray booths and robots to the MindSphere platform. Also introduce new applications like maps to monitor the booths at a higher level. With that, the presentation comes to an end. Thanks a lot for attending. Now we are open for questions.